first one is supposed to be all contained in the box, but it didn't, so that's fine. All telephone numbers are preceded by a 3-digit area code. In the original Bell telephone system of assigning area codes, the first digit could be any number from 2 to 9. The second digit was either a 0 or a 1. This is not true anymore since we have like 587 and some weird things going on. And the third digit could be anything except 0. Anyone know what numbers we could put in here?
The one at the very end.
Yep. What else?
Put 2 in the middle. And then 8 for the first one.
Now the saddest thing is when people go 9 here or 7. It's a scary situation. So if you have to count on your fingers, that's way better than getting it wrong. Wait, what is it? 2, 3, 4, 5, 6.
I made a mistake. The very far right is a 9.
Yeah, I see that. It is a 9. What are you seeing? I see like it's got invisible ink.
Yeah.
See what I'm saying?
Absolutely.
And then there's like
a write that.
Yeah. I'm sorry. That's my fault.
I was wondering how there was 16.
Too late to apologize. No, it was a 9 the whole time. I didn't loop it. So, sorry. And when we multiply that, we get what? 144. Perfect. What do you want?
Just throw something at me.
Oh. Oh. We'll get that one later. There. Those are really hard to throw. They have like, their weight is off. It like moves around the Skittles. I'm not throwing Skittles. What did you say? Skittles? 1 minute. 1 minute. I won't throw it. It's gonna stick. That's what makes me do that. Okay. So, password for a certain computer program. Where did I put my? Needs to be an arrangement. What does that mean? Yes.
That means it's a permutation.
Yeah. Permutation of 4 characters consisting of letters and digits from 0 to 9. How many letters are there in the alphabet? 26. Okay. You know what I'm going to do? If you guys... All right, back to this. So there are 26 letters, we agree. And there are 0 to 9. How many numbers? So optional, we have how many numbers and letters?
In total 36.
In total 36. Then we got to keep reading, right? So if the letter Y is considered to be a consonant, what is the number of 4-character passwords that either begin with a consonant or means I do what? Add. I get a new case. Or have no consonant at all. So I'm going to do that. Okay. Who's going to help me out? What's my first option on this blank? 21. Then we put some multiplication symbols because we need each one to make the 4-digit number. Yep.
It's 36.
Why? You're right. Yeah, but why?
Because you can have any consonants and you can have all the digits.
Yeah.
For 0.
Yeah, and you can have any vowel, right? There's no limitations on this one. So we have 36, 36, 36. A lot of people forget to bring the digits back, or the vowels, or a mix of different objects. Okay, the back 4 blanks, what can they be? Yeah.
They'll all be 15 because you only have 5 vowels.
Yeah,
And then 10 numbers.
You got it. And then we have to multiply because we need each digit. And what does that get us? A, B, C, or D? Voila. All right. The next one, we have an airline company requires flight attendants. Lewis, I'm coming for you. You're ready. Flight attendants to wear a pair of pants, a shirt, a tie, and a blazer. Appreciate that. All right. How many options do we have there? 4. Boom, 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 boom. Not sure why I did them up here, not down here. Whatever. Oh, that's because that's a question. Cool. The flight attendants have a choice of 3 different pairs of pants, 5 different shirts, 4 different ties, and 2 different blazers. We can use blanks. Why, Lewis? How many are we choosing of each? How many pants do we have to wear at one time?
Just one.
Just one. One of each, right? So that's why we can go to the blanks. So what do we put in the first blank? Then? Because we're picking one of each, I can do the blanks. Sorry, carry on. What did you get for an answer?
I don't.
I agree. The maximum number of outputs. Why do I have two boxes? I think these got bumped, hey? We're gonna, yeah, right there. Okay, cool. I don't know what's going on with my print.
I think the box is just over the question.
It's I just want it to snow. Ah! Okay, whatever. We'll take that. I don't know what just happened, but cool. All right. It froze for a second there. The next one is the number of three-digit numbers. Sending three blanks. Less than 400 that can be formed if the last digit must be a 4 or a 5. Peyton, less than 400 tells me I have to do what? Yes. So my first digit could be a 1, 2, or 3. Why can't it be a 0? Yes, and you missed all that explanation from the first 2 days, but you just rocked that. So look at that. High five. Here's some oxygen. Cool. Okay, so where do we have to start? At the restrictions. So Peter, where are we going to start?
I would start
Yep. What do we have here?
2,
Then,
3,
then,
10.
then. What do I get?
6, 16.
Yeah, it would be in the boxes, but, well, mine's not working. Okay, this one, NP2 equals 110. Now, how this question could be set up is, I walk into a room full of people. How many, I don't know. I can feel people around me, but I'm not sure how many. Because, boom, a wall went up. And I was like, oh no, I don't know how many there are. But what they told me was that I needed to choose a president and a vice president out of the group of people that just slammed. I'm like, is it 7? Is it 8? I don't know. They're like, but what I'm going to tell you is there are 110 different ways I can pick the vice president, president from that room of people you just saw. Bam, a wall went up. How many people are there? That's how that question could be asked. Then you'd be like, oh, I don't know N, right? But I do know I need a president and a vice president, which means it's a permutation because order matters, because I gave them jobs, correct? And then I told you there's 110 different ways. Gave you an answer. Shabam, this question, right? So, then we have to solve it algebraically, which means we can't just go like 3p2, 4p2, 5p2, 6p2 into our calculator until we get 110. Now, I know you could have gotten away with that because it's multiple choice. Therefore, this won't be asked as a multiple choice. It will be asked in a written response and asked to do algebraically, right? So, we're going to use our formula. We get n factorial over n minus 2 factorial equals 110. And we expand, so we get n minus 1, n minus 2 factorial over n minus 2 factorial equals 110. They cancel, and I get n squared minus n minus 110 equals 0. What multiplies give me negative 110 and adds give me negative 1? Negative
11.
and positive. So I get n equals 11. Checking my calculator, it works. N equals negative 10 makes no sense. I can't have negative 10 people and I choose 2 of them, right? It doesn't make any sense. So I circle it, I put a line through it, and I say?
Strenuous.
Yeah. Last one. Looky here. It seems as if I picked the same thing over and over and over. Okay. Until you just like do it in your sleep, right? How many 6-digit numbers are there without repetition? 6-digit numbers. It's supposed to say, oh, it does. It says even, which is what it needs to say. I just bypassed that word completely. My brain just blocked it. Even 6-digit numbers. And then without repetition. So I'm going to need 2 cases. The back number of 1 has to be a. And the other one has to be?
2, 4, 6, or 8.
So I start with a 0. I have 1. Then I have 1 to 9. I'm going to box and hold that 0. I have 1 to 9, which is 9. Hold the 9. Then I have 1 to 8, which is 8, then,
7,
then,
6,
then. So that one's an easy one. This one's a little more complicated. Here I have 4, say I hold the 8. Then I can have 1 to 7 and 9, which is how many? 8. I hold the 9, then I have 1 to 7, which is just 7. Is that true? No, I can bring back the 0 because I couldn't use it in any of the other 2 blanks, right? So then I have 8, hold the 0, and now I can count down. 7, 6, 5. When you multiply them and add it, what do you get?
16,880.
880?
Yeah.
Look how pretty that number is. So many 8s. So little time. Okay? Cool. So we're going to deal with permutations with restrictions, which we've already kind of dealt with, but then we're also going to deal with, hey, there's words in the world that actually have letters that are more than one of the same thing. Because all we've done is we've done always so far words that are like English or kitchen, ones where they're like every single letter is a different letter. We haven't dealt with ones like pool, where the 2 O's are the same, right? So if I swap the 2 O's, it actually still is the same word. So we're going to deal with those today too. So ones with restrictions and ones with repetition. So example 1. Find the number of permutations of the letters in the word kitchen. Now they don't have to say permutations because words are permutations. Because opal and pool are different words, right? Or like loop. Totally same thing, different word, right? So order matters in words. If you change the letters, it makes a different word. We say word loosely because we aren't like looking it up and seeing if it's a true word. We just means that they look different, right? All right. Now sometimes you have to read, well not sometimes you have to read, you always have to read, but sometimes you have to look really closely because sometimes it's like 4-letter words out of the word kitchen, or sometimes they're arranging the whole word kitchen. Like you have to read to see if it's the whole word or if it's just a few of the words, few of the letters. All right. So here it says permutations of the letters in the word kitchen if the letters K, C, N must be together but not necessarily in that order. Okay? So we need our thinking caps today. So we're still arranging all of kitchen. And I check, I have 1 K, 1 I, 1 T, 1 C, 1 H, 1 E, 1 N. I know I have 7 letters. And I know they're all different. So I'm going to have 7 blanks. 1, 2, 3, 4, 5, 6, 7. Now it says K, C, N have to be together. They could be together at the front or between the first 2 letters or the next 2 letters, the next 2 letters, the next 2 letters, or at the back. And it would make all different words with K, C, N together. We agree? So the easiest way that I think to deal with it is to actually put them together at the very front and then move them after. So I always, when it says something has to be together, I hook it together at the front. So I'm going to hook these 3 letters together. And I'm going to force KCN to be hooked together so they're stuck together. We agree? Now it says not necessarily in that order, so it doesn't have to be K, then C, then N. It could be any of the order in itself. So it actually has a little permutation inside the permutation. So if KCN can be in any order, how many options do I have for this blank?
3.
I have 3. So I'm just going to write them all out. Later on you probably won't do this, but I'm going to show you anyways. So there's 3. And the moment I'm using letters, I know I can't repeat because I only have I have the tiles, right? I have 7 tiles, and the moment I use one up, I've used it up. We agree? So we're going to box and hold every single time we do letters, just like when we did the no repetition of digits, because you're actually keeping it there, right? So I'm going to pick one of them. I'm going to keep the K. You could keep the C or the N, it doesn't matter. Now for this blank, I only have C and N, so I have 2, then say I have N, then I only have C, which is 1. Now I've actually boxed and held all 3 of those letters, so they're gone. I can't use them anymore, right? So I do have left the I, the T, the H, and the E, right? For the rest of the letters. Does it say anything else about the rest of the letters? No. So you don't have to show these all, but I am just for this one. I, T, H, and E. So now I have 4 letters. Say I keep the E. I have I, T, H. I have I and T. And then I have I. And then I have to make sure that I multiply. Now the answer to this will be on the diploma, this answer. It's not right. Because we're not done. Because I said K and C have to be together, correct? So currently they are together, but is that the only place they can be together? No. There's a whole bunch more spots I can pick that together up and move it into a different spot and see it. Okay? Don't write this down. I'm just going to show you something. So I'm going to show you all the different options, and then I'll show you how quick it is to not do it this way, because this is longer. So this is my one option. I have 3, 2, 1. Don't write these out. You don't have to. I'm just proving a point. 4, 3, 2, 1. Then I could take them and I could put them between these two letters, right? Between the E and the H, and it would make me a whole nother different word, correct? But they'd still be together. So I could go 4, 3, 2, 1, 3, 2, 1. And it would result in the actual same number, wouldn't it? Because you're still multiplying 3, 2, 1 times 4, 3, 2, 1, just out of order. And then I could put it between these two. So I could go 4, 3, 3, 2, 1, 2, 1. And then I could go 4, 3, 2, put it between these ones, 3, 2, 1, and then 1. Or I could put it right at the back, 4, 3, 2, 1, 3, 2, 1. How many cases is that? 5. Okay? Now you could draw out every single case each time, or you can know that it's always one more than the number after they're hooked together. Because I visualize it, oops, this way. I go, okay, this is one way. Then I can put it here, which is 2, 3, 4, 5. It's 5 ways, right? It's always one more than this number here, the number after them hooked together. So it'll be times 5. And then it actually ends up being a really nice number. You can go 3, 2, 1. What's 3 times 2 times 1? How can I write that nicely? 3 factorial. Yeah. And then I can go 5 times 4 times 3 times 2 times 1, which is 5 factorial. Is this 5 times 4 times 3 times 2 times 1 is 5 factorial, correct? So it'll always result in a second factorial because it's always one more than this. You see that? So if this number had been a 7, it would be 7, 6, 5, 4, 3, 2, 1. I would multiply it by 8. So it's one more. So that is 720. And how do I know that? Because Chris just said 3 factorial is 6 times 5 factorial. 6 times 5 factorial is actually 6 factorial, and I have 6 factorial memorized as 720. That's the only reason why I did that. So you can do it in your head by reasoning. But 3 factorial, 5 factorial might just be the answer. They might say, determine all the ways that you can do this in the form a factorial, b factorial, where a is less than b. She survived. It was the downfall of the fun dip. Fun dip is not fun.
This happens more often than you think.
Yeah, there should be a warning on the fun dip.
She's forgotten. Hopefully.
Still has, she's good. So if they go in the form a factorial, b factorial, where a is less than b, write a, b in numeric response, you would go 3, 5, right? You could do that as well. That's what they can ask you in numeric. All right. Here's the next one. I'm going to star this one, because this one everyone forgets about. Most people kind of forget about this one, but you practice it enough, they're fine. This one people forget about, because you don't do it in the way that you kind of think you would. So number of permutations, arrangements where order matters, of the letters in the word kitchen if the vowels must not be together. Key thing here is not be together. Okay. Thinking caps. We're all thinking right now. Okay. If I ask you what would be the quickest method to figure out how many students are in this school but not in this class, what would be the quickest method? Would that be A, walk around to all classes, count the people, tell everyone to not move, creep yourself into the bathrooms, count those people too, because that's super weird, and then you look in a hallway, and then you count all those people, then you go to Nancy, and you be like, Nancy, who's all absent today? And then you count all those people, and then poof, you have the answer as to how many people were not in this class. Would that be the fastest way to do it? No, that would be silly. You guys will try and do that. You guys will try and come up with all the cases where the vowels aren't together. You're going to miss one or two, just like I missed 50 people somewhere randomly in the school tucked where I don't know where they are, right? So that's not the fastest way. What would be the fastest way to find out how many people are in this school but not in this class?
people in this class, subtract that from the total number of students.
Yeah, be like, hey, Mrs. Atkinson, do you know how many people are in this, how many students are in the school? And she'd be like, there's blah, blah, blah. I don't know how many. Then you'd be like, hey, Mrs. Lepp, how many people are in this class? And I'd be like, there's 21. And then you'd go, okay, subtract them, and poof, you'd have people not in this class, right? You'd subtract actually the opposite of what you think. So what we're going to do is we're going to find out all the ways I can rearrange kitchen without any issues. Like absolute maximum number of ways I can rearrange the word kitchen. How many different words can come out of all those 7 letters, correct? And then I'm going to subtract off what?
All of the ones that the vowels are together.
All the ones where the vowels are together, and what's left over, the cases where the vowels aren't together. So you're actually not finding the ones where the vowels aren't together. You're taking the total number of different ways I can find kitchen, subtract off the vowels together, and then what's left over are the extra cases, the ones where the vowels are not together. Right? So how many different ways can I rearrange kitchen? No restrictions. Anyone know? 7 factorial. Because I'd have 1, 2, 3, 4, 5, 6, 7. I'd have 7 letters for this, then 6, then 5, then 4, then 3, then 2, then 1. So this would be kitchen, no restrictions. Is that 5,040? I can't remember. Okay. So, fun fact. You can go home tonight. Hey, fun fact, Mom and Dad. Did you know that there are 5,040 different words I can make with the letters in the word kitchen? And they'd be like, oh, cool, 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 cool. So that's the maximum number of different words you could get out of the word kitchen, right? Changing the I's, the T's, the C, the H, the E, the N, and moving them all over, putting different letters in the front and everything like that, right? Maximum number of words. So now, if I subtract off all the ways the vowels are together from that 5,040, what's left over are the ways the vowels aren't together, correct? So now I need to find out all the ways the vowels are together. So we do what we did in the previous one, but now with the vowels. How many vowels are in kitchen? There are 2. There's an I and an E. So I'm going to hook together 2, correct? How many options do I have for the first blank? 2. Then I hold one of the vowels, so how many do I have for the next one? 1. And I've used up 2 letters. So how many letters do I have left for the last blanks? I've used up 2. How many do I have left for this one? 5, then 4, then 2, 1. And then what do I have to remember to do? Times it by 6. So it's 1 more than this. If you don't know that, you can still count. 1, then between here 2, 3, 4, 5, 6, right? It's always 1 more than the hooked together number. So that is going to be 1440. It's 6 factorial times 2. We're going to subtract off 1440. And what do we get when we do 5,040 minus 1440?
5,600.
Yeah. So is that a lot faster than trying to be like, okay, so if I put a vowel in the first line, don't put one in the second, put one in the third, those are separated. Okay, then I figure out. Okay, if I put a vowel in the first, not in the second, I put it in the fourth, first, then fifth, then first, then sixth, then first, then seventh. Okay, now second and fourth. Second and fifth, second and sixth, second and seventh. Okay, then third and fifth, third, sixth, like, we're at case like 700, and this is like taking forever, and I'm probably going to miss one, right? So not the best way. So if you catch yourself on case like 7, be like, there has to be a better way. There's no way she would be this. You're right. There would not be a way. It's probably this question. Okay? All right. Now we have the word oranges. Does the word oranges have any doubling or tripling letters? Nope. So in how many ways can we can all of the letters in the word oranges be arranged? O-R-A-N-G-E-S. 7 letters again. There are no further restrictions. The first letter must be an N. The vowels must be together, O-A-E. And in that order, specifically. And then example 3, in how many ways, how many arrangements of the word brains are the vowels together? And then I want you to try this one. So we're doing 2, 3, and 4. Try them out. So we'll go through this wherever you are. It's okay. So the word oranges, 7 letters. There are no further restrictions. I'm arranging all of the letters. You have to read. Sometimes it's 4 letters, and then you'll put 7 factorial, and it's just the saddest day. Okay? If it was 4 letters, it'd be 7 times 6 times 5 times 4, and you'd stop, and then just multiply them. So you have to watch if they're arranging the whole word or if they're arranging just some letters. So here we're arranging the whole word, so it's 7 factorial, which is 5,040. Then it says the first letter must be an N. 1, 2, 3, 4, 5, 6, 7. So the first letter must be an N. Then I have 6 letters left. 5, 4, 3, 2, 1, which is 6 factorial, which is 720. Then this one says the vowels must be together in the order O, A, E. That matters. Now sometimes you also have to watch. Sometimes they'll say the vowels must be together in the front in the order O, A, E. Then I wouldn't move them. Then I wouldn't multiply by 6 or 4 or 3 or whatever it is, right? So if it says that the vowels have to be together at the front or the back or the middle, then you don't have that extra number because you're not moving them around. Okay. 1, 2, 3, 4, 5, 6, 7. They have to be in the order O, A, E. So it's going to be 1, 1, 1, not 3, 2, 1. How many letters do you have left? How many letters are left? 4, then, and then I have to multiply it by 5. Because they could be here, which is one way, 2, 3, 4, or at the back, which is 5, because it doesn't say together at the front. Now 1, 1, 1 doesn't do anything. 5, 4, 3, 2, 1 is 5 factorial, or 120. Then we have the word, and how many of the arrangements of the word brains, B-R-A-I-N-S, there's 6, are the vowels together? There are 2 vowels. So we go 1, 2, 3, 4, 5, 6. Now we have to hook together the vowels. There's 2, then 1, then 4, 3, 2, 1. And then I have to multiply it by what? 5. Always one more than the number after they're hooked together, right? So it's 2 times 5 factorial, which is 240. Then we have example 4. Example 4 says, in how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can be together? So I have 1, 2, 3, 4, 5, 6, 7. I have 7 in a row. What do I have to start with in order to have no genders together? Because there's more of them, right? So this would be boy, 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 and then this would be girl, girl, girl. So I would have 4, 3, 2, 1, and then 3, 2, 1. The reason why I did them in different colors is the red makes what? 4 factorial, and the black makes
3.
Which is? I want you to try that question. Same question, but now 4 boys and 4 girls. Try it out. How many ways can you rearrange 4 boys and 4 girls so that not 2 genders are together? 4 boys, 4 girls. So, 4 boys and 4 girls. Some might say 4 factorial, and say you're done. Most people will start with boys again because that's what we started with last time. So it would be 4, 3, 2, 1. And then these would be girls. So 4, 3, 2, 1. Make sure you have your dots. Which would be 4 factorial, 4 factorial. And that answer will be there, and it's wrong. Yeah. It's multiplied by 2. Why?
Because you have to swap who's first.
Right. You could start with boys first. Or you could start with girls first, and you'd end up with 4 factorial again. Correct? So it's not just 4 factorial times 4 factorial. It's 4 factorial times 4 factorial times 2, because it could be girl, 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 and then boy, 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 boy. Right? So that's going to be, I don't know what that is. Pardon? That's 4 factorial times 4 factorial times 2. Thank you. Now, the last one here says 6 actors and 8 actresses are available for a play with, and this should say this, and I keep forgetting to change it, I just changed it in my notes. It should say 4 different male roles and 3 different female roles. Does order matter if you, in this? In what role you get? It's like giving you a different job, right? Giving you a different role, order matters. If they were all the same role, would order matter? No. That's why I had to specify different or same, but I didn't specify anything, so it's just confusing the way it was. So if I say different, they're all different roles. It's like if someone wants to be Romeo, but you get picked as another person in that play, which I don't remember anyone but Romeo and Juliet, hence why it's called Romeo and Juliet. That's all I got. There's like the Capulets, isn't there? And then Mercutius. Yeah. That right there is all I remember. It's been a tick since I was in high school. Just a couple years. So, if it says different male roles, order matters because you could get different jobs or different roles in this case, correct? So you could go with blanks, you can, but we know if it's P's, we could just use the P, couldn't we? So how many males do we have to choose from? 6 actors. So 6, and then we'd P 4, and then we have 8 actresses, so it would be 8 P 3. If they were the same role, what would be the only thing that changes here? The P's would become C's. You just don't even know about those yet. Because it would be a combination, because the order wouldn't matter. If they were all the same roles, it wouldn't matter if you were picked first, second, or third, or fourth of the male roles, because you get the same role. Okay? Now, do I need to multiply them together or add them? Why?
Because it's the male roles and the female roles.
Right, we want 7 roles picked out of this whole thing, right? If I put a plus sign, it's an or. Then I'd be picking the males or the females, and I'd be happy. I need all of them in order to put forth this play. So I multiply them. So everyone type that into their calculator. So what do we get?
20,960.
Okay, then we're flipping over and we're looking at the word basketball. Ruh-roh.
Would we ever put a situation in this where, like, even though, like, the female roles aren't going to be played by the same person, like, would there be a case where, like, 2 roles are played by the same person? And
I hope not.
We wouldn't have a
Never
combination.
seen something like that. I've seen combination and permutation mixes. And I'll give you examples of that once we learn combinations, but it would be more like a perm-com mix would be, I give you 2 words. I think one's like frog and one's like another pile. So like the 2 words don't have any letters that are the same, right? And what they say is, okay, pick 3 letters from frog, 2 letters from pile, and then make a new word. So you'd use C to get the 3 letters from frog and the 2 letters from pile. So you do like 4C3, 4C2 to just get the letters. Now, poof, I have 5 letters in my hand. I chose the letters, I got the letters, because the order didn't matter then. I just got some letters, right? I use C. So now I have these letters, I have 5 letters. Now what do I have to do with these 5 letters? Make all the permutations. So I would multiply by 5 factorial. So I would have a combination to get the letters, and then I'd have a permutation to arrange the letters. So that'd be a perm-com mix. So it'd be the same if I had this committee, and I chose 3 people from this committee and 2 people from this committee, and then I formed a new committee and gave 5 jobs, 5 factorial. Then I'd have to order them. So I get people, arrange people. So that'd be the perm-com mix.
Thank you.
I hope they never do that, what you just said. Changing really quickly, getting into another position. That's what I have to do in small town Saskatchewan. We have to like play multiple roles because there wasn't enough people to play every role. Fun. Okay, we have the word basketball. Look at this. Or Peter. We have all these different words. What is the thing here? They have letters that are the same now instead of all being different, correct? So let's look at the word basketball. Okay? How many different 10-letter arrangements are there in the letters of basketball? Here's basketball. Are these two words different? You're like, no. Well, I'm a magician, and I swapped the L's. When I was typing these, I was like, erase, erase, and then I swapped the L's and I retyped it. I did not. But let's pretend I did. Do they look any different? No, because the L's are exactly the same, right? It's the same as I told you if I had 5 cars and they were all the exact same model, all the same color. I told you close your eyes, and I flip-flopped them and I put them all back in like different spots, but exactly looking the same. You wouldn't be able to tell, right? Now you're like, oh boy, how do we get rid of all those cases? Because if I have to think about all the places where the L's are the same to get rid of them, not only the L's, but there's also 2 A's like this, that would suck, right? And 2 B's. Oh my goodness. There's a really easy way to get rid of all of those cases that are the same. Let's see how. So I'm going to arrange basketball, and I always, always, always pretend in the numerator that all of the letters are different. But I was taught this by a tutoring kid back in the day. I think they went to the comp. So I'm bringing some comp into HTA. It is actually a genius idea, so I keep doing it. What they did is they had their students write out the letters and stack them if they doubled up. Because what happens is people will miss a doubling up letter, or at least if they stack it, they may be like, why am I stacking these? All right, I have to do something extra because I have doubling and tripling letters. So you go B, A, S, K, E, T. Oh, now I have another B, so I stack it. B, A, L, L. So now I know that I actually have 2 B's, 2 A's, and 2 L's. At the very least, I'm like, why am I stacking these? And I'm like, oh, right, I have to do that little extra thing, right? It was a genius idea, so I stole it, and now I use it all the time. But I give credit, I just don't remember who it was for. But it was someone at the comp. It might not even be there anymore. It's been lots of years. Okay? So what we do is we treat the numerator like they're all different letters. Okay? I pretend the B's, you could tell the difference. I pretend the A's, you can tell the difference. I pretend the L's, you can tell the difference. And then there's one little step at the end that gets rid of all the cases where they're not different. Okay? So it's a 10-letter word. I want to rearrange it. I'm pretending they're all different. How do I rearrange a 10-letter word with no restrictions? 10 factorial. It would be just 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We agree? So it's just 10 factorial. Now, they're going to have the answer to 10 factorial there for you. It's a really large number. If I'm not going to give the number, they'll write 10 factorial. But they're going to have that there because this would be the case if you didn't realize there's doubling and tripling letters, right? Common error. Now, how do you get rid of the doubling and tripling letters? All you do is you divide by factorial the numbers. So I have 2 B's, I'm going to go 2 factorial. And then I have 2 A's, I go 2 factorial. I have 2 L's, I go 2 factorial. I do not write 6 factorial because this is 2 times 2 times 2, which is actually 8. 6 factorial is 720. They are not the same thing, okay? So you do whatever it is factorial, whatever it is factorial, whatever it is factorial, okay? If you have the old calculators, so the TI-83s are the ones where the exponent doesn't pop up, you have to make sure that you put your denominator in brackets or you will get this question wrong every single time. Because your calculator, fun fact, the only thing you know for sure that your calculator will always do is order of operations. That calculator in front of you is programmed to do order of operations. So if you don't put brackets, it's going to go 10 factorial, divide that by 2 factorial, and then what's it going to do? Take that answer, multiply it by 2 factorial, take that answer, multiply it by 2. That's what it's going to do. That's not what you want it to do. You want it to take 10 factorial and divide by all those numbers. We agree? So the only way you can force your calculator to do that is force order of operations. What comes before the multiplication and division if I can put brackets? Brackets, right? It's brackets. Exponents, right? So if you want something to happen first in your calculator and guarantee it will always happen first, put brackets around it because it has to do it in order of operations. It will have to do that first. If you have the fancy new calculators, you can just press the fraction button. Follow along. If you don't know if you have the fancy calculators, follow along and be sad if you don't have this function. So if you have the other ones, no problem. Just you always have to remember to put brackets around that denominator to make it happen first, right? If you have the fancy ones, you can do this. Second, y equals, that's a lie, alpha y equals, I meant. So go alpha y equals, enter, and a fraction pops up. If you do alpha y equals, enter, a fraction pops up. If you have the fancy ones that you can recharge, put a cord in. Yours is even faster. You can just go alpha link, the button beside it. So if you have the ones with the colored ones where you plug them in and they recharge, you just go alpha and then link, the one right beside it, and the fraction will pop up. If you have the TI-84s, you have to go alpha y equals enter. If you have the ones in between, you just have to do brackets. It's totally fine. You just all get the same answers. Okay? But you do 10, math, factorial, and then over 2. So now it's going to do it in, do I have to go 2 factorial though? I'm just going to go 2 times 2 times 2 because that's the same thing. Oops, I have a bracket in there. Then enter. Okay? Now, say you mess something up and you're like, oh, I need to go back. Remember, you can just go up here and steal it. Bring it back. If you're someone with a TI-83, you still can steal your answers. You just can't go up. You have to go second entry. So you have to go second enter, and it'll pull your previous ones back up. If you don't have the TI-84s or the rechargeable ones. The TI-83s, you have to just go second enter, and it'll pull second enter, second enter, second enter, and it'll keep pulling back all the stuff you've done. Okay? You can also insert something. So say you forgot a number in here, you can go second insert and put like 1. Now I have 12. I don't have to retype the whole thing. That's another thing. It was not a 12. Don't put that. That's just stupid. So it's 453,600. So literally, that's the only difference. You treat, so even if they said vowels have to be together, correct? You go, you do vowels together, you pretend all the letters are different. So say you have 3 A's, and the vowels have to be together. You'll go 3, 2, 1, treating them like they're all different. And then at the end, what are you going to do? You'll just divide by 3 factorial for the 3 A's. So you treat the top like they're all different letters. Does that make sense? And then you just divide by the factorials, the bottom gets rid of everything. So even if you're like, well, they don't look any different. You pretend they look different. I have 3 A's. I can tell them apart. I can't. I'll just deal with that after. Okay? Your homework is down here, but I'm not going to give you, oh, it's over the next one. It's large. I'm not giving that much. So follow along, and then we're going to downsize it. So it is page 524. So do the last unit first. I know that's weird, but it's so that you can keep practicing it as the year goes on. So, four is literally typing factorials into your calculator. I just saw you do it, so you're fine. 5 is doubling and tripling letters, so this one's a good one to check. 6 is good. 7, just do A. 8 we're doing tomorrow, so I don't want you to do it. I'm just going to go like this, right? 9, 10. So 5, 6, 7, 8, 9, 12, 16, 17. I'm trying to stick to 8 to 10 questions max today, trying to get you to do things, and then trying to do a bit more during your notes. So I am making you practice ones during your notes too.